Okay, so yesterday we talked about binary ionic compounds. Okay, those were made with two types of elements. Now we're talking about tertiary ionic compounds. What do y'all think tertiary means? It means 3 or more. Okay, so tertiary ionic compounds can have 3 or more types of elements in them. So let me give you 2 examples. Okay. What is this first one? Is it binary or tertiary?
Binary.
Binary. How did you know? It's only 2. Good. And then what about the one on the right? Tertiary. Good. Anytime it has 3 or more, it's going to be tertiary. Okay, so today we're going to be learning how to write the chemical formulas for tertiary ionic compounds. Okay. So tertiary ionic compounds always have a polyatomic ion in them. Okay. We've already learned a little bit about polyatomic ions, but it's really important to remember that they act as one unit. Okay, so for example, nitrate, even though it's a nitrogen bonded to 3 different oxygens, this whole thing acts like one unit and has a -1 charge.
NO3?
NO3, and it's got a -1 charge on it. Okay, so we know that ionic compounds, you have to make sure the charges cancel. So if I had this nitrate bonded to calcium, which has a +2 charge, I would need 2 nitrates, right? To balance out the charges. So how would I write a subscript for a polyatomic ion? What do y'all think? Let me show you. So if I had it bonded to calcium here, I would need to group NO3 in parentheses and then write my subscript on the outside. Okay, so make sure you have written down that you use parentheses and the subscript goes on the outside. Okay. I'm going to move this up a little bit.
Can I substitute? Oh, I'm sorry.
No, go ahead.
Substitute for the CA?
So the subscript is for the nitrate. Okay, whatever the subscript is directly next to is what it is telling you. Like, for example, in the nitrate, there are 3 oxygens, but this 2 right here, since we put the parentheses, applies to the whole nitrate ion. If you want to break it up like that, yeah. But this is how we write it, okay? We have to group the ion because it acts like one unit. Okay, so let's do another example. Let's do barium nitrate. Okay. So remember, our first step whenever we're writing formulas is to do what? We'll find the charge, but even before that, we need to write the symbols. Okay, so barium, does anyone know? Ba, good. And then what is the formula for nitrate? Nitrate is NO3. And what's the charge on nitrate? Just a -1. Good. What's the charge on barium? 2 positive. Good. So, what's my next step? I will need to put the parentheses on it because I'm trying to balance the charges. Okay, so my positive side has a +2. My negative side has just a -1. So I need to add more negative stuff, right? Okay, how many more nitrates do I need? Just one more. Okay, so when I write out the formula, I'll write BA, and then I have to group the nitrate with the parentheses. Make sure you still keep the 3 because nitrate is NO3. And then what subscript will I put on it? 2. Good.
It's all tertiary.
What'd you say?
That's for all tertiary ionic compounds.
They're always going to have a polyatomic ion in them. So if you need multiple, you have to use the parentheses. Okay, does anyone need more time on this? Or can I turn the page? Turn the page? All right. Let's do some more examples. Right? How about lithium chlorate? I didn't think I need all of them. I just wrote choices. With the okay.
Transition.
All right. So step number 1, what do I do? Write down the, what'd you say? Say that again?
Symbols.
The symbols, yeah. Sorry, I can't hear over here. All right, so what's a symbol for lithium? Li, good. And then we need to figure out what chlorate is. So chlorate is our polyatomic ion because it ends in 8. Okay, so if you pulled up that chart where you made the polyatomic ions, find chlorate. What's the formula for it? Good. So it's Cl O3 with a 1- charge. It is chlorine bonded to oxygen, but it's specifically bonded to 3 oxygens with a -1 charge. Okay, so this whole thing is chlorate. Okay, and then what's the charge on lithium? +1.
How do we know that?
Good question. We know that lithium is one that has a fixed charge. So any in our main groups, our 1A through 8A, are always going to have a fixed charge. So lithium's in group 1. It's got 1 valence electron that it's always going to give away to make that +1 charge. Okay, so what do I do now? Do I need to do anything to make the charges cancel? No, because they already cancel, right? +1 and a -1 are going to cancel. So I can just write my formula, right? Okay, so I'm just going to write LiClO3. And remember, when you write your formulas, you don't write the charges in there. It should just be letters and numbers. Okay. Let's do.
Lithium has a subscript, we would have to do a parentheses.
So if lithium needed a subscript, we would not do parentheses because lithium is monatomic. So we would just put it right next to lithium, like right in there. Okay, let's do chromium. All right, now we've got chromium 2 cyanide. Okay. Do y'all remember what this Roman numeral 2 means? Not how many chromiums there are, but it does tell us something about chromium. The charge. Why do we have to specify what chromium's charge is? It's in the middle. What do we call those? Transition metals. Chromium is a transition metal, which means it can have a variable charge. Okay, it might form a +2, it might form a +3, so we have to say which one it is. Okay, does anyone know the symbol for chromium? Cr, and what's its charge? 2 positive. And then can anyone tell me what cyanide's formula is? This is our polyatomic ion. So you're not going to find the polyatomic ions on the periodic table. You're going to have to look on that chart that you pulled up on your laptop. Oh, I'll tell you cyanide. It was on the PowerPoint. Cyanide is carbon and nitrogen with a -1 charge.
Can you put 1 minus, or it has to be like this minus?
You can write 1-. It's not necessarily wrong, but you don't have to put the 1. All right, so what do I do now? I've got the symbols and I've got the charges. I have to cancel out the charges. Okay, so I've got a +2 over here. And I've got a -1 over here. So do I need more positive or more negative?
Yes.
More negative. How many more do I need? Just 1 more. If I add another cyanide, then this becomes a -2, and they cancel. Okay, so what formula am I going to write? Cr, and then I need 2 cyanides, so I got to group them together. I'm going to write Cn, and then I'm going to put the 2 on the outside of the parentheses. Okay, how do we feel so far? Pretty good? All right, let's do... calcium phosphate. Okay, so step number 1. Write the symbols. So calcium is Ca, good. Does anyone know what phosphate is? PO4 with a 3- charge. And what's the charge on calcium? +2. How'd you know? Because it's in group 2. All right, so this one is one that's not easily figured out by just adding an extra ion, right? So we're going to use our crisscross method to solve this one. Okay, so remember we cross the numbers here, and we just ignore the charges. You cross the numbers, so 3 will go with calcium, 2 will go with phosphate. So when I write my formula, what's it going to be? Ca, and it's going to get the 3 because the 3 crosses over. And then I'm going to write phosphate, PO4. I'm going to put it in its parentheses because it needs a subscript. And it's going to get the 2. Okay, so do you see calcium had the 2 charge, phosphate had the 3, and we just swapped the numbers? Okay, so that's our final answer for that one.